Hello class. In this video we'll be reviewing how to find the constant of proportionality and how to write equations. Now this video will be covering both subjects, so if you have to retake either of these assessments, please be sure to watch this entire video because if you don't know how to find constant of proportionality, you won't be able to write equations. Now before we go into the video, you will be required to copy a couple definitions down. Now, the constant of proportionality, or sometimes it's called COP, is just the unit rate in a proportional relationship. Now, there are times where there's no COP in just a unit rate, but the key to this definition is the proportionality part. Without that, there is no constant of proportionality. Now, we will be talking about independent variables as well, and if you remember from class, it's usually the x value, and I want to make sure that you understand that this is important right here. So you might want to put a square or underline this part, but it's usually the x value, and this variable does not rely on another variable. It makes its own decisions. The dependent variable is a little bit different, and the reason is because it's instead of the x value, it's considered the y value. And that variable's value depends on the independent variable. So if there's no independent variable, the dependent variable won't know what to do. So make sure that you also note that the fact that it's the y value is also very important. And lastly, for those of you who have to retake the equations section of the assessment, an equation is a statement that the value of two mathematical expressions are equal. So the easiest way to put this is 1 equals 1, or 1 plus 1 equals 2. Both of these sides of the equation of the equal side mean the same thing. 1 plus 1 is the same thing as 2, and 1 is obviously the same thing as 1. So it's just a way of balancing out two mathematical statements and saying that they're equal. Now let's actually go into some important information you'll need in order to find COP. Now the first thing you'll need to remember is that in order to find COP, you'll need to know the equation y over x. But what this really means is this means that your dependent variable will be divided by your independent variable. Now, you'll also need to be able to tell what's dependent and independent. Now, the easiest way to do this, and if you're lucky enough for this to be your ratio, or to be your comparison, is that time is always an independent variable, because no matter what happens, time will always continue. Time does not rely on money, time does not rely on a length of anything. Time is just its own thing that goes on without anybody else's help. And another important thing to note is that when you're looking for what's dependent and independent, for example, if time isn't one of the units that you're comparing, you try to think to yourself of an item that relies on another for change. So a lot of times this is money or wages, or if you're looking at a plant, time might be your independent variable and the length of the plant would be your dependent variable. There are a couple other examples that you might look at. Now, for example, on this side, on my left side, I'll be talking about COP, my constant of proportionality. And on my right side, I'll be talking about my equation, for those of you who are just looking at this video for the equation section. Now, the first thing I'll need to do is determine what's my dependent and independent variable. And I can see I have hours, and that's going to be my independent variable, or my x, because time goes on without anybody else. And miles is going to be my dependent variable, or my y value. So the number of miles we drive depends on how long we're actually driving. So I'm going to be using my equation of y over x to find my COP. In this case, I can use any of these pairs. I can use, for example, 100 divided by 5, or I could even use 240 divided by 12. If this table is truly proportional, it doesn't matter which one of these rates that I use, but no matter what we do, we're going to see that we have a COP of 20. So this will be my COP no matter what pairs I choose to divide by. So if you're just looking for COP, that would be my COP. Now, if you're writing an equation, you want to take a second look at your table. You know that the number of hours you multiply, or the number of hours you drive, is multiplied by 20 to come up with your distance of miles. So, I'll just come up with a couple random examples. I know that if I multiply 20 times 8, that gives me 160 miles. If I multiply 20 times 12, that'll give me 240 miles. If I multiply 20 times 15, that's going to give me 300 miles. If I'm trying to come up with my equation, I can see that my 20 stays stable. That doesn't change, which is true because it's my COP. My constant, meaning it doesn't change, my constant proportionality. So in my equation, I'll just put my 20. Now the 8, the 12, and the 15, those represent the number of hours that I've been driving. So I'm actually going to write two equations. They're the same thing, but you'll see why. So I'm going to have 20 times x, or on this side, 20 times h. 20 times the number of hours I drive is going to equal 160, 240, or 300, aka the number of miles that I've driven. Now you're going to see a lot of equations that take this format. It's going to be a constant of proportionality times x equals y. Or you might be able to come up with your own equation based on the units you're using. So in this case, 20 times the hours equals the number of miles. Either way, either of these equations do work. I would just say that on an assessment or in any assignment, if you do use x and y, because you are thinking about dependent and independent variables, you're going to want to label that x is hours and that y is the number of miles, just so that whoever's reading your information knows what you're talking about. So let's look at a different example with another table. So here we have the population of Newtown, USA. You can see that we're comparing the years to the population. So automatically I know years is a unit of time. That's going to be my x value. Population is going to be my y value. I'll use my y over x. And again, I can use any of these pairs. I'll just use 300 over 2, since that's my easiest value to calculate. And I can see that my COP is 150. Now, if I want to write my equation, I already have my COP. If I want to write my equation, it's going to be useful for me to write a couple of examples. If you already know the trick to writing equations or you see the pattern, you can move ahead. But you can think to yourself, well, if I multiply 150, so we're going this way now, times 150, 150 times 2 gives me 300. 150 times 19 gives me 2850. So you'll see that the 150 times the number of years is equal to the population of this town. Or you can use your x and y variables just like this, and you can see that the 150 times your your independent variable of years is equal to your population, which is y. Now I do want to note that this y and this y are not the same, because this just happens to be my my dependent variable. So you may want to label that x equals the number of years and y is equivalent to the population. I'm just going to put pop. So either way, any of these equations that you use is totally fine. If you just use this equation, I will take that as full credit. And if you use this equation, I will take it as long as you also include what x and y stand for. Now in this equation, in this table, you can see that there's no units of time. We're comparing the number of IDs to the cost that you'll have to pay for those IDs. So you're going to try to think to yourself, what depends on the other? Is the payment or the cost dependent on the number of IDs, or are the IDs dependent on the cost? Now you'll have to think to yourself, well, if I buy a single ID, that's going to be $5, and if I buy more IDs, that changes the price. So you have choice over how many IDs you buy. You don't have a choice of what price they set for IDs. So in this example, X is going to be the number of IDs. This is my independent variable. Y is my cost. And I can pick any of these pairs. I'll just pick 100, so Y over X. My Y value is 100. My X value is 100. My Y value is 500. My X value is 100. And if I divide this, I'm going to get 5. So my COP just by itself would be 5. Now my equation in this example, so for example, if I had my $5 for each ID, 5 times 4 IDs should give me 20. I know that 5 times 500 IDs, hypothetically, if I wanted to buy the entire school IDs, that would be $2,500. So I know that I'm going to be multiplying my 5 times the number of IDs that I purchase would give me the cost. Or if I wanted to use X and Y's, I could say 5X equals Y, where X is the number of IDs and Y is the cost. So this would be sufficient for your final answer for an equation, or this, including what X and Y stand for, would be sufficient for your equation. Now, in my next two examples, I don't have a table, I just have a short story. So here I have 800 tickets that were sold for $32,000. Now, I mentioned earlier in this video that most times money is going to be your dependent variable. How much money you make depends on how many tickets you sell. So I'm going to label that this is my Y variable, just up here. The 800 tickets is my X variable. If I want to find my COP, I'm going to divide 32,000 by 800. That's going to tell me that each of these tickets was $40. So my COP would be 40. Now, if I wanted to write an equation with this, I know that each ticket's $40, so 40 times the tickets we sell is equivalent to the amount of money we spend. So this would be okay for an equation, or I could say 40x equals y when x is the amount of tickets and y is equivalent to the amount of money we spend. Now we also have another example over here. Charles ate 4 servings of hot chips and consumed 28 grams of sodium. So again, we'll use our equation y over x. And you think about it, the 4 servings and the 28 grams, the grams of food that you eat depend on how many servings you've consumed. So I'm going to say that 28, or my grams, is my dependent variable. My servings is my independent variable. So if I divide 28 by 4, I get a COP of 7. So this alone, this 7, would be my constant of proportionality. And then my equation, I'm just going to do this real quickly, would be 7 times the number of servings equals the number of grams of sodium, or 7x equals y, when x equals the servings and y equals the grams of sodium. So either this would be your final answer, or this would be your final answer. Now we're going to look at a couple of graphs next. And finding your dependent and independent variables here is actually quite easy because you've known from an early age that the horizontal axis, the one that goes side to side, is your x-axis. Your y-axis goes up and down. So I know that the hours that we work is equivalent to how much we're paid. So what I'll be doing here is I'll be looking for an ordered pair. And if you don't remember what an ordered pair is, there's actually quite a few on this page. I can see one here. There's actually infinitely many ordered pairs, but the easy ones to see are the ones that are going to cross these bolded lines. And if you remember, an ordered pair is always labeled x, comma, y. So your x value, comma, your y value. So in this case, I'm just going to pick this ordered pair over here, just a random ordered pair. This ordered pair is 4, comma, 20. So I know if I worked 4 hours, I'll make $20. So when I know that, I'm still going to use the same old equation, my same old equation of y over x. I'll be dividing 20 by 4, which will give me a value of 5. So my COP just by itself, by looking at this graph, would be 5. If I wanted to write an equation about this, it's going to be similar to what it is. I know my hours is going to be dependent, or independent, I should say, because we read our graphs going left to right, and we can tell, well, if we want to work 4 hours, if we want to work 9 hours, that's completely up to us. The pay is determined by the hours in combination with how much we make per hour. So in this case, my equation would be 5 times x equals y, or I could also say 5 times my hours equals my pay. But remember, if I use the x and y, I have to label that x is the number of hours and y is the pay. So again, you can take this as your answer or this as your answer if you're looking for an equation. Now my last example, you're going to notice that there's not quite as many ordered pairs. Now there will be some people who will try to examine, and I'll make this a little bit bigger so you can see it. They'll try to examine where the line crosses the y-axis, or the y value I should say, and it's kind of hard to tell here. You can't really tell. So your best bet is to actually find a clear ordered pair. So I don't see one at 1, or 2, or 3, or 4. I really don't see one until I get to 5. And this ordered pair would be 5, 40. And remember, our ordered pair always goes in order of x, y. So if I want to find the pay at Walmart, I'll be dividing 40 by 5 to get a COP, of 8. And as always, if I'm looking at a graph, I should know that my equation is going to be dependent on my hours or my independent variable. So my equation would be 8x equals y, or 8 times the number of hours we work equals the pay. And remember, x is the number of hours, y is the amount of pay. So now that you've seen these examples, please remember that once you are done taking these notes, that you do have to complete your retake activity that's on Power Learning. If you have any other questions, please let me know. Thank you.